This is part 2 of the EGR series. In this video, I'll be discussing the 6.7 Cummins diesel EGR cooler assembly and its functions and whatnot. Now, just a little layout of the engine. So this is the 6.7 Cummins. This is a 2013 picture, by the way. You can tell by the coolant here. There's two coolant lines. And there's two radiators. So anyways, you got your cooler that sits on top of the exhaust manifold. This is your bypass actuator. Your bypass valve is here. Crossover tube, so your EGR temperature sensor, your EGR valve, your intake horn which sits under here, and you got your butterfly valve here. This is your EGR cooler on a pickup truck model. You can see the EGR cooler which is bolted to the exhaust manifold in the back, and then your bypass valve right here and bypass valve actuator right here. It is also bolted to the exhaust manifold towards the front. You can see the picture of how it looks when it's all bolted together. On your cab and chassis models, you don't have a bypass valve. So you can see where the EGR cooler is bolted to the back of the manifold, and you can see this plate right here. It's blocked off. This is where the EGR bypass valve is usually bolted to. Got your crossover tube, EGR temperature sensor, and then your EGR valve. Your valve is controlled by two valves in here that open up that allow gases to get in. You see your butterfly valve here, right? Your butterfly valve, same thing like the power stroke, right? It closes off a certain amount of air to allow the inert gases to enter. Some more images here. This is a 2008 model, but essentially it's a good picture. You can see it gives you a good look at it. You see the internals of the valve. This is a 2007 picture of 6.7, but the cooler itself hasn't changed much since. So the overall, functions of the EGR doesn't change from Series 1. But there are some differences between the Fords and the 6.7 Cummins. Ford uses a two-cooler design. Two coolers put into one. The Cummins is just one cooler, and it's this right here. And this is for the cab and chassis models. For the pickup models, they use a bypass valve, and all of that is also explained in the first video. It's the same, essentially the same function. A little bit of straight exhaust gas is routed into the engine at low speeds. So just like the power stroke. So there's no real, change to that. Everything's dependent on speed and engine load. Basically, EGR is active at low load and speed ranges. Control of EGR flow is based on engine load and engine speed. The ECM gathers information from the engine input sensors, and after evaluating the input sensors, uses a stored performance map to operate the EGR valve, just right here, the air butterfly valve, which is down here. It's kind of hard to see on this one. The circulation allows for a precise EGR flow. So from here to here to here and then to there, and then also using the butterfly valve to close off some air. There's no need to discuss kind of how these things function because they're essentially all the same like the first video, except here everything's monitored by the ECM. The RAM also, the Cummins has a EGR temperature sensor. The EGR temperature sensor is located on the EGR crossover tube right here. The temperature sensor is a negative temperature coefficient thermistor. It's used to measure the temperature of the EGR gas flow after it exits the EGR cooler. The ECM supplies 5 volts to the EGR temperature sensor circuit. To determine the temperature of the EGR gas flow, the ECM monitors the change in voltage caused by changes in the resistance of the sensor. The ECM uses the exhaust gas recirculation temperature valve for the engine protection system, as well as for controlling its emissions. So from 2007 and a half, when the 6.7s first came out in the Rams, all the way to 2012, The EGR cooler itself required cleaning at every 67,500 miles, somewhere around there. You take the EGR cooler off, the crossover tube and the valve, you take all this off, and you have to clean it. In 2013 and a half, when Ram introduced diesel exhaust fluid into their system. Now, EGR is used to reduce NOx, oxides of nitrogen. Well, with the introduction of SCR and diesel exhaust fluid in 2013, the amount of EGR that went into the engine was greatly reduced, because the whole purpose of EGR is to reduce NOx. SCR does the exact same thing. SCR reduces NOx by a significant amount. So because of that, in the 2013 to current models and beyond, on the 6.7 Cummins, EGR is reduced. Okay? Because of that, ever since 2013 and a half, with the new 6.7 Cummins with the DEF SCR system, you no longer have to perform an EGR valve cleaning at 67,500 miles. Okay? You no longer have to do that. It is not required. You don't believe me? Go read your manual. Okay? Now, some dealerships, some diesel mechanics, some of them, believe this or not, believe this or not, they don't know that. So even on a 2018 or 19, the new models coming out, some of them will still say, oh yes, you still have to conduct an EGR cooler and EGR valve cleaning. But you don't. You don't have to. The perform service messages that come up during that time is for the CCV filter, not valve, filter, excuse me. Part of the 67,500 mile maintenance is to change out your CCV filter and to clean all your EGR systems. You no longer have to do that. You just change out your CCV filter and that's it. That's all you got to do. So I've made this a point in previous videos, that the point of my channel is to present information that most people don't know about, and even some dealerships don't know about. For instance, OCR on the Fords. A lot of dealerships don't know about that. Just because they don't know doesn't mean it doesn't exist. So, same thing with the maintenance of the EGR cooler on the 6.7 Cummins 2013 with the DEF systems and up. You don't have to remove your cooler and EGR valve to clean it. You don't got to do that, because it uses a lot less EGR. These things don't get gunked up like they used to. So, anyways, this is part 2. I think this is sufficient, but I may do a part 3. But as of right now, that's it.